Hey guys, so today let us take a look at distributed tracing and OpenTelemetry in Kubernetes. Now, distributed tracing is a method for tracking requests as they flow through a distributed system. This is what helps us to diagnose performance issues and also to pinpoint where failures might occur. And the tool that helps us do this is OpenTelemetry, which is an open source observability framework. So OpenTelemetry provides standardized tools like APIs and SDKs for collecting, processing, and exporting telemetry data. And this includes traces, metrics, and logs. Take a look at this, for example. I've installed what is known as a trace storage backend with Grafana and Grafana Tempo in a Kubernetes cluster. In the Explore tab, in the Grafana dashboard, if you set your data source as Grafana Tempo, you can view and inspect trace telemetry data. So each trace represents the complete journey of a request as it flows through a distributed system, like in our case, a microservices application running in Kubernetes. And quickly, we can see that we have multiple errors with our application because we have warning indicators on each of the traces. So if we expand one of the traces, we can see all of the stages of this request. So first, the HTTP post request from a worker microservice to an API is successful because we have an HTTP status of 200 or OK. And then second, the API microservice itself also reports a successful receipt of the request on its orders endpoint. However, the next phase, where the API attempts to store data to a database, is not successful. So some kind of error is indicated at this phase. And then when you expand the trace to get more details, you can see that the error has something to do with the table name. So perhaps a new version of the API application was pushed with a bug in the code and a wrong table name was used. So simply by looking at this, we know where the issue is and we know what the issue is as well. So we can just simply update the code for the API application and push a new update. So using distributed tracing, we're able to quickly diagnose and pinpoint the source of issues. And this is the power of OpenTelemetry. It can be a very useful troubleshooting tool. So let us see how we can enable OpenTelemetry for our applications in a Kubernetes cluster. First, we need to understand this concept of a trace and a span in OpenTelemetry, because what we want to do is to enable applications to produce spans, which are what make up a trace. So a span is a single unit of work within a trace. It represents a specific operation. Now, this could be an HTTP request, a database query, or any other kind of operation. So this particular span, for example, represents an HTTP post request to an API microservice. We can see some of the information that's typically contained in a span, like the name, the type, and more specific information about the operation in the attributes. And most importantly, we know the status of the request. So we know that this particular part of the request was successful because we have an HTTP status of 200 or OK. And then we also know not only what happened, but also how long it took because of the start and end timestamps. So this is really powerful for troubleshooting performance issues, especially in cases where requests are not completely failing, but are perhaps a bit slow. And then another important part of the span is the trace context, which contains the span ID and the trace ID. The trace ID is how we know which spans belong with each other, because a single request can go through multiple microservices. So related spans will have the same trace ID. And then each service can communicate the trace context to the next service by including it in the HTTP headers of a request. So that is a brief overview of how traces and spans work. You can get more details by looking at the documentation. So what we want to do now is to enable our services to start producing trace telemetry data. And we do this through a process called instrumentation. Now, OpenTelemetry provides language-specific SDKs and APIs for instrumentation, so we can use them to easily collect, propagate, and export trace data in our applications. And this is done regardless of the programming language that you've used to develop your application. So as you might already suspect, this involves modifying the code of your applications through manual instrumentation. Now, there are many advantages of manually instrumenting your applications. When you do this, you have full control over what gets instrumented, and you can have customizable spans, attributes, and metadata. So you can really create complex or unique tracing configuration. But there are cases where you already have multiple workloads running in a Kubernetes cluster. You do not wish to invest any more development effort. And what you're really looking for is a simple out-of-the-box tracing implementation. And then this is where you'd prefer using the zero code or auto-instrumentation method. It is quick to set up with minimal code changes. It covers most of the common libraries and frameworks out of the box, and it's also great for instrumenting existing workloads in cases where you have a lot of applications already running in production. In Kubernetes, the auto-instrumentation is done by the OpenTelemetry operator. So you simply describe how you want your applications to be instrumented in an instrumentation CRD, and the operator will take care of the rest for you. So to get started, obviously we start by deploying the OpenTelemetry operator to our cluster, and then the operator itself has a dependency of Sat Manager, so we make sure we have it running in the cluster first. So we can use this manifest file from the OpenTelemetry GitHub project to install OpenTelemetry and all of the required CRDs. Now, OpenTelemetry also ships with another component called the OpenTelemetry collector. So this is basically a standalone service that is going to act as a collector. It's going to receive and process and also export telemetry data like traces. You can have a central location for collecting the data before sending it to a storage backend like Jaeger, Zipkin, or Grafana Tempo. And so we can deploy a collector using this manifest. So the main thing to note in this manifest is the receiver configuration, where the collector is going to receive these exported traces. So we have the HTTP and gRPC endpoints where the applications are going to be sending traces. And then the exporter configuration is where the collector itself will export the traces for storage and visualization later on. So this is a storage backend like Grafana Tempo, for example. So this means we also need to deploy a tracing backend, and we're going to do that using Grafana and Grafana Tempo. So this will help us to store and then query the traces efficiently. So we can get the Helm charts for both Grafana and Grafana Tempo from the Grafana Helm repository, and then we can deploy both components to a monitoring namespace, for example. So if we access the Grafana dashboard via port forwarding, we can log into the Grafana dashboard and then add Tempo as a data source in Grafana. So once done, we can use the Explore tab for visualizing and inspecting trace data. So now we have the OpenTelemetry operator and the collector installed in our cluster. We have Grafana Tempo running as a trace backend. So what we have is an entire framework for instrumenting applications, collecting and storing traces, as well as querying and visualizing trace data. So what we can do now is do the actual instrumentation of the workloads that we have running in the cluster. So we can create an instrumentation manifest like this. In this manifest, we specify where the application should export the traces, and this is the OpenTelemetry collector's HTTP endpoint. And then we also make sure to propagate the trace context so we can mark related spans as part of the same trace. And then if we need to add additional OpenTelemetry configuration, if this is required, we can add that as environment variable. Yeah, so after we create this instrumentation resource, we need for the deployments to opt in to the auto-instrumentation. We can do this by updating the deployment manifest, and we add the instrumentation annotation into the pod template like this. And then we update the deployment for the configuration to take effect. Now, once this has been done, this should recreate the pods for each of the deployments that have been instrumented. So we can check if the instrumentation has been successful, and we can do this by describing one of the pods. Each of the pods should have an additional init container added. So this is the container that's going to run at startup, and this is the one going to be responsible for automatically instrumenting the application at runtime. We can also see these additional OpenTelemetry environment variables, which means that actual OpenTelemetry configuration has been added to the application. We can also check the logs, and you can see that there are traces being exported to the console. Also, in addition to traces being exported to the console as per our instrumentation manifest, we're also exporting them to the collector. So at this point, we should be able to see all the traces viewable in the Grafana dashboard. So this is a simple getting started guide on how you would enable tracing for your existing workloads in Kubernetes with OpenTelemetry and also using zero-code instrumentation. So thanks again for watching, and if you find this video useful in any way, please leave a like. And I'd like to thank everyone that watches my videos and that is currently subscribed. Thank you a lot for the support. This really means a lot. My aim now is to be more frequent or more regular with posting content at least once or twice weekly. So if you like this kind of content, please make sure that you're subscribed so that you don't miss an upload. So thanks again for watching, and I'll see you in the next one.